This is the PowerPoint for Chapter 7, The Logic of Sampling. We're going to be talking about a brief history of sampling, non-probability sampling, the logic and techniques of probability sampling, populations and sampling frames, types of sampling designs, multi-stage cluster sampling, probability sampling in review, and the ethics of sampling. So sampling is the process of selecting observations to be part of your research design. So I just want to give a couple examples that show just how important selecting the right sample is to the results of your research. So in the 1930s, Literary Digest mailed 10 million ballots to ask people who they would be voting for president, and 2 million ballots were returned. They predicted that Alf Landon would be president, but Roosevelt ended up winning in a landslide. So the problems with this type of sampling, so only 1/5 of the respondents sent back their ballots. Also, the sampling frame included those with telephones. So this is in the 1930s, and at the time, this was the more wealthier people, and these people generally vote Republican. So a similar thing happened with President Thomas Dewey. So Gallup's sample was unrepresentative. They relied on census data that was several years old, and the population had changed since then. So we can see, and again, they predicted that the wrong person would be president. So we could see just how important sampling is to the results of your research project. So non-probability sampling is any technique in which samples are selected in some way that's not suggested by probability theory. So several types of non-probability samples are available subjects, purposes of sampling, snowball sampling, and quota sampling. So the first is reliance on available subjects, and this is also called convenience sampling. So in your project at the end of the semester for class, most of you will probably use available subjects. So this doesn't allow to control over representativeness. So you can't generalize this to the larger population because you're really just using whoever is available. So for example, if you say I'm going to interview the first 10 people who walk through this door, that's not a representative sample. It's only justified if less risky methods are unavailable. So researchers must be very cautious about generalizing when this method is used. So one reason that this method might be appropriate, if you're simply pre-testing a questionnaire, not necessarily doing a research project, but maybe you want to see how people are answering things on a questionnaire, you might use convenience sampling. The next type is purposive or judgment sampling. So this type of non-probability sampling in which the units to be observed are selected on the basis of the researcher's judgment about which ones will be the most useful or representative. So these are small subsets of a population. Usually they use two-group comparison. Subjects are chosen because they fit a specific purpose. So if we want to include right-wing students, maybe we'll sample from the Young American for Freedom Club. The next type is snowball sampling. This is a non-probability sample method whereby each person interviewed may be asked to suggest additional people for interviewing. This is often used in field research with special populations. So this is usually used when they're hard to reach segments of the population for which there's no sampling frame or list of possible people that could be included in the sample. So some topics that might be appropriate for this would be interviewing undocumented immigrants, homeless people, and even active burglars. So one of my mentors in graduate school actually did a project where he interviewed active burglars, and he used a snowball sampling method. So he knew of one active burglar that obviously knew a bunch of other ones, and the one was able to give him access to all his burglar friends and referred them to be part of the research study. So quota sampling is a type of non-probability sampling in which units are selected into a sample on the basis of pre-specified characteristics, so that the total sample will have the same distribution of characteristics assumed to exist in the population being studied. So similar to probability sampling, but this has problems. Quota sampling, the quota frame must be accurate, selection of sample elements may be biased. So this method is appropriate when you want to get a snapshot of the kind of same characteristics people have in the larger population. So these could include age, race, gender, year in school, ethnicity, etc., etc. So an informant is someone who is really well versed in the social phenomenon that you wish to study and who is willing to tell you what he or she knows about it. So like I was saying in my mentor's research project on active burglars, he used an informant and got really close to this one guy that was able to kind of show him the world of burglary and kind of introduce him to other burglars. So there's several problems with this. First, the informant might be a little bit different than the other subjects that you wish to reach. You might only have access to the people the informant knows in the population, and you might miss out on entirely different sections of the community that you wish to study. Okay, so now we're going to talk about probability sampling. This is a general term for samples selected in accord with probability theory. This is always used when you're doing a really expensive, large-scale survey. If all members of a population were identical in all respects, there'd be no need for this sampling procedures, but this is rarely the case. So a sample of individuals from a population must contain the same variation that exists in that population. So we do this in order to make inferences about the larger population. Of course, there's some unconscious and conscious sampling bias. So a bias would be that those selected are not typical or representative of the larger population. So maybe you're going to ask people with a certain characteristic to be part of your sample simply because you feel more comfortable talking to them. So that would be an example of a bias that you might have when selecting your sample. So selecting and observing those people who are most readily at hand is the simplest method, but is unlikely to provide a sample that accurately reflects the total population. This is just a little illustration from your textbook. So you see your population includes white men, women, and African American white men and women, but your sample could totally miss out on an important segment of the population here, which was African Americans. So representativeness is the quality of a sample of having the same distribution of characteristics as the population from which it was selected. So if the population is 50% men, 50% women, then you probably want your sample to be 50% men and 50% women. So samples don't need to be representative in all respects, but only those relevant to the research question at hand. So a sample will be representative of the population from which it's selected if all members of the population have an equal chance of being selected in the sample. This is called the equal probability of selection method. So there's several advantages to probability sampling. So they're typically more representative than other samples because biases are avoided. And probability theory permits researchers to estimate the accuracy or representativeness of the sample. So there's several different terms I want you to be familiar with. So the first is element. This is the unit of which a population is composed in which it's selected in a sample. So in most social research, elements are people, but they could be families, zip codes, cities, countries, etc., etc. The population is a theoretically specified aggregation of the elements in a study. So say we want to study Texas Tech students, this would be the population. But a study population is a sampling method in which each element has an equal chance of selection independent of any other event in the selection process. So maybe your study population is, instead of all Texas Tech students, is full-time students on the Lubbock campus. So a very important part of probability sampling is random selection. So this is when each element has an equal chance of selection independent of any other event in the selection process. So a good example of this is flipping a coin. So whether it's heads or it's tails does not depend on whether the last few flips were heads or tails. There's always the same chance of being selected, which is a 50-50 chance because there's two elements here. And then a sampling unit is the element of set of elements considered for selection in some stage of the sampling. So probability theory, sampling distributions, and estimates of sampling error. One important term to know is parameter. So this is a summary description of a given variable in a population. So this could be the income of all families in a city, or maybe the age distribution of a city's population. This is just a little example from the textbook about parameters and populations. So let's imagine a population of 10 people with differing amounts of money in their pockets, ranging from $0 to $9. So this example, the mean or the average amount of money these people have is $4.50. So if we pick 10 different samples of one person each from this 10-person population, our estimates of the mean would range all across the board. So they would be very, very different. But if we increase our sample size to 2, the possible samples provide somewhat better estimates of the mean. So we wouldn't get either a 0 or 9, so they would start to cluster a little bit closer to the mean, which is 450. So if we keep increasing the sample size, the possible samples cluster even more tightly around the true value of the mean. So the chance of extremely inaccurate estimates is reduced at the two ends of the distribution, and the percentage of the samples near the true value keeps increasing. So here we can see how generally you want to have enough people in your sample so that that true value really clusters around, the sample value really clusters around that true value. Okay, so a few more important terms to know. First is statistic. So this is a summary description of a variable in a sample used to estimate a population parameter. And then a sampling error. So this is the degree of error to be expected of a given sample design. So this sampling error formula contains the parameter, the sample size, and the standard error. So shifting to a more realistic example, let's assume that we want to sample student attitudes concerning a proposed conduct code. Let's assume that 50% disapproves, though the researcher does not know that. So we have a large student body. Let's suppose that we selected 3 different samples, each of substantial size. We'd not necessarily expect those students to perfectly reflect attitudes of the whole student body, but they should come reasonably close. If we were to select a large number of good samples, we would expect them to cluster around the true value of 50%. But given enough such samples, a few would fall far from the mark. Okay, so confidence levels. These are the estimated probability that a population parameter lies within a given confidence interval. So in social research, we usually say that we're 95% confident that our sample falls within a certain number of percentage points of the population. So for example, 10%. But this 95% is the usual confidence level that we're using in social research. So a confidence interval is a range of values within which a population parameter is estimated to lie. So let's say that our mean is 1.23. Maybe our upper confidence interval is 1.29 and our lower confidence interval is 1.16. So maybe we could say that we're 95% confident that our true value falls in between those two confidence intervals. Okay, so another important term to know about in this chapter is a sampling frame. So this is a list of units composing a population from which a sample is selected. So if the sample is to be representative of the population, it is essential that the sampling frame includes all members of the population. So a sampling frame, for example, could be a telephone directory, it could be census tracts, it could be a student roster, etc. So basically a list of all the possible elements that could be part of your sample. So a couple guidelines for populations and sampling frames. The findings based on a sample represent only the aggregation of elements that compose a sampling frame. Sampling frames do not include all the elements their names might apply. Omissions are inevitable. So of course there's going to be unlisted phone numbers, there are going to be people that move away from their houses, sampling frames are out of date, there's maybe a few students that were not available on the roster. So to be generalized, all elements must have an equal representation in the frame. So now we're going to talk about a few different sampling designs of probability sampling. So we have simple random sampling, systematic sampling, stratified sampling, and implicit stratification in systematic sampling. So simple random sampling is a type of probability sampling in which the units composing a population are assigned numbers. So a set of random numbers is generated and the units having those numbers are included in the sampling. So it's not necessarily the most accurate sampling method, but it's the most easiest to do of the probability methods. So for example here, having numbered everyone in the population, we can use a table of random numbers to select a representative sample from the overall population. So anyone whose number is chosen from this table is in the sample. So another type of systematic sampling. So this is a type of probability sampling in which every numbered unit in a list is selected for inclusion in the sample. So it's slightly more accurate than a simple random sample. So say a population has 10,000 people and you wanted a sample of 1,000 people, it simply means that every 10th person would be selected from your sampling frame. So a sampling interval is a standard distance between elements selected from the population of the sample, and a sampling ratio is the proportion of elements in the population that are selected to be in a sample. So stratified sampling. So this is the groupings of the units composing a population into a homogeneous group, which is also called a strata, before sampling. So it's slightly more accurate than simple random sampling, and it's a modification to simple random and systematic sample methods. So it involves two stages. So first, the members of the population are gathered into homogeneous strata. This simple example merely uses gender and race, but any different variable can be used. Then every numbered case, so in this case, every 10th person in the stratified arrangement is selected into the sample. So an example using Texas Tech students, maybe instead of using the entire student roster, you separate it into freshman, sophomore, junior, and senior, and then pick every 10th person in each of those categories or stratas. So cluster sampling. This is a multi-stage sampling in which natural groups are sampled initially with the members of each selected group being subsampled afterwards. This is used when it's not practical or possible to create a list of all elements that compose the target population. So it's highly efficient, but it's less accurate. So in multi-stage cluster sampling, we begin by selecting a sample of the clusters. So in this case, it's city blocks. Then we make a list of the elements, so households in this case, and then select a sample of elements from each of these selected clusters. So probability proportionate to size sampling. So this is a type of multi-stage cluster sample in which clusters are selected not with equal probabilities, but with probabilities proportionate to their sizes, so as measured by the number of units to be subsampled. So this is a more sophisticated form of cluster sampling. So we use this when the clusters are different sizes. So maybe these city blocks, one of them has 100 houses on it and another street has 10 houses on it. So instead of taking an equal number from each of those, we would sample more houses. We would sample more houses from the street that has more houses on it. So weighting. This is assigning different weights to cases that were selected into a sample with different probabilities of selection. So maybe we're more interested in a particular area of the city, so we sample more households on those particular streets and weight them heavier. So probability sampling and review remains the most effective method for selection of study elements because it allows researchers to avoid biases in element selection, and it permits estimates of error. Of course, it comes with their downfalls. The first is it's very expensive to do, and it takes a long time. Sampling frames may be out of date. You don't always get everyone that you need to be part of your sampling frame. There's always going to be a little bit of bias there, but it's much less biased than non-probability sampling methods. So probability sampling always carries a risk of errors. Researchers must inform readers of any errors that might make results misleading. And when non-probability sampling methods are used, researchers must take care not to mislead readers into confusing variations with what's typical in the population. So if you're using non-probability sampling methods, which you will be doing for your final project, you have to make sure you note in the limitations that your sample is not representative of the larger population. So chapter summary, we're able to highlight some of the key events in the development of sampling and social research. We can describe what is meant by non-probability sampling and identify several techniques. Identify and explain the key elements in probability sampling. Explain the relationship between populations and sampling frames and social research. Be able to highlight some of the key events in the development of sampling and social research. Describe what is meant by non-probability sampling and identify several techniques. Identify and explain the key elements in probability sampling, and explain the relationship between populations and sampling frames and social research.